Hello, everybody. Welcome to another wonderful episode of MET-RELATED Pep Talk. And in this episode, I'll be running you through how to create, a spread sort of plot or a spread analysis, which I'm terming here as a plot flow. So in some cases, you want to visualize your data with its variability in the sense that you would want to have the mean and then also show the spread of that data around the mean. And so to do this, in this case, I'll be making use of the mean, the 25th percentile, and then the 75th percentile. Now you are free to explore with whichever percentile ranges you would want to work with as your spread. And that's also permissible, that's also allowed. Now I'll be making use of the ERA5 data set. So first off, I import xarray as XR. And I also import numpy as NP, because I'll be making use of some numpy functions. And then I would also import matplotlib .pyplot as PLT. And this will be for the plotting functionality. All right, so to start off, we read our data set, which is there are 5 data sets, into the variable data. So we use xr.open underscore data set on the ERA5 data set. All right, so we can run this whole script and our data set is loaded. So we first would like to see what the data contains. So we try with the variable data dot data underscore vars. That gives us the data variables. We see in here there are a whole lot of parameters, and all these data sets are 4-dimensional because they vary over time, the level, which is the pressure levels, and then the latitude and longitude. Now these are atmospheric data sets. For the purposes of this work, I'll be making use of just the Q, which is the specific humidity. So first off, to get the mean, I would have to define a new variable, which is Q, and that will be data.Q. Now that would be for the specific humidity data alone, all right? And so now I would want to create the mean of that. And then the mean, I'm going to conserve one of the dimensions, which is in this case the pressure level, because I want to see how the parameter varies over the various pressure levels. So I want to see it spread along the various pressure levels. So I would conserve that dimension and then rather find the mean over the other dimensions. So in here, I define the dimensions to average over, which is in this case, the time, the latitude and longitude. All right. And then from there, I would also define my 25th percentile values. So now let's define a new variable called Q25. And then we call our data.Q, which is for the specific humidity. And I'm going to make use of the reduce functionality. And this allows me to pass another function directly on the XRE data set. In this case, I'm going to make use of the np dot the percentile, the np dot non-percentile, which is the percentile functionality. So I bring on board np dot non-percentile. And then, because I'm going to conserve the level, in this case again, I'm going to use the same dimensions as stated at first. So I can just copy this and paste here. So that means I'm finding the percentile values over these 3 dimensions and conserving the levels, that's the pressure levels. Then I define the percentile value to use. So I want the 25th percentile. So that's Q equals to 25. And then I duplicate this whole line. This time, I want this to be for the 75th percentile. So I change the variable to Q75 and then make the Q value 75. That's the 75th percentile. And that's all. This produces the mean of the specific humidity. The line 18 produces the 25th percentiles. Then line 19 produces the 75th percentiles. And all these I expect to vary over the pressure levels. So now we would want to visualize the data set or our plot. So let's create the figure environment first. So create a plt.figure, and then from there we can now plot. So we have plt.plot. We are plotting. Our x-axis will be the Q, which is the mean, and then our y-axis in this case will be the pressure level. Bear in mind, because we conserve the levels when we're finding the mean, we can just call that same Q and then dot level. And we expect it to produce the pressure levels. Now, let me run this first so we see what we have. Okay, so we have a plot like this with the pressure from 0 to 1,000. But in actual sense, I want it to be the reverse, the opposite, because you would want the pressure levels to rather decrease as you're going upwards. So there are various ways of doing that. One of the simplest ways I decide to use is to go back to the plt.ylim and then reverse my maximum and minimum. So I start from 1,000 to 0, and that reverses it. Okay. So 1,000 in this case will be either close to the surface or the surface in most areas, and then all the way to the vertical part. That's the upper atmosphere. And now this is just the mean. To also have the spread around it, we are now going to use the plt.fill between. Okay, but then because I'm filling between, now I want the spread to be on, it should vary over the y-axis, but then it is a spread, it's a spread that's made up of variables over the x-axis. So it means I can't just use fill between x. I can't use the fill between, but rather fill between x. That means the fill would be like a range, it would be ranging over the x domain, but then it's varying over the y, but then it's actually a fill that's sort of an area spread, okay, or sort of like a whole spread that's over the x-axis as we are changing in our y steps. So I'm going to make use of the fill between x in this case. And then this time I define my y, which is the q dot level. So our pressure level is going to be conserved. And then the spread would be between the Q25 and then the Q75. And this should be enough. All right, and that's how we create a spread or a plot fill. Now we can also reduce the opacity of the spread, so we can see the mean directly within it. So I can include in here alpha equals, and then let me use a value of 0.25. All right, make it 0.45. Yeah. Okay, so that's enough. So with this, we can see the mean and then the spread of the data. And the spread in this case is from the 25th to the 75th percentile. And then as custom demands, let me just label my x and y axis to finalize the plot. So we have plt.x label, and the x label in this case will be specific humidity, or let's say Q, which is in gram per kilogram. Okay, and then you can increase the font size by including font size and then a value, let's say 14. All right, then we can do same for the y axis. So plt.y label, Then the variable is the pressure, given in hectopascal. And again, we can increase the font size. And that's it. So once we are done with this, we can save our final image. So let's say plt.savefig. And they're supposed to save the file, the figure, to a file. So I just define the file I want to save to, let's say, spread.png. And that's all. And this should save my output to a PNG file named as spread. And so going back to all the various steps we've gone through, you'll be able to do this by selecting, different domains of your data set and then creating the spread plots of it. And this is very key to, easily study the variability of a data set, and also it's looking at the spread in the data set. And it's very useful in the field of climate science, in the field of even in the field of data science, and a whole lot of science-oriented areas. And I hope you enjoyed this video. And like I always say, the top is still huge enough to accommodate each and every one. So I hope you would push with all the efforts that you have, push yourself, make sure you excel in your learning of programming, and then see you at the top. Best wishes. If you haven't subscribed yet, don't forget to subscribe, turn on the notification bell, and like this video and leave a comment. Have a wonderful time and keep achieving. Bye.